Hello friends, welcome to this new video. In this video we are going to perform Normalized Difference Vegetation Index, Normalized Difference Water Index, Normalized Difference Built-up Index, and we'll perform Land Surface Temperature or LST as well. So let's open Arcgis. So we will create a blank map here and then we will add data. Okay, so here we are. We will take data from 2018 and we will copy paste data of band 3, band 4, band 5, band 6 and band 10. So later in this video we will require all of these bands. Anyway, so first of all let's take the Bangladesh map. So here is the sub-district map of Bangladesh, as you can see here. Our study area is here, so let me crop it first. And then we will go to geoprocessing and then clip. The input raster will be bgdadmin3. Then output data will be the same as well. And then we will just click OK. Now as you can see we have a new admin clip. So this is the clip. This is our research area. And now I'm going to clip it. And there are actually multiple ways to do that, but I prefer this one. Just right click in the Arc toolbox, the clip data management tool, and input data we can start by band 3 and the output extent will always be clip 4. And don't forget to click on here, use input features for clipping geometry. You have to do that unless there will be a square rather than the study area, which is a polygon. So we will keep doing it for band 4, band 5, band 6 and band 10. Okay, so this is the cropped version of our research area. So now we will rename it to band 3 for our convenience and we will repeat it up until we get all of these files together. We can remove all of those files that we no longer need. So remove, and we have removed all of those. Now we actually don't need to click on all of those figures, so first let us do Ndvi calculation. And to calculate Ndvi from Landsat 8 we need band 5 and band 4. So the equation is NIR minus red divided by NIR plus red. So band 5 minus band 4 and band 5 plus band 4 for Landsat 8. Okay, so here we are going there and write raster calculator, and here it is, the raster calculator of spatial analyst. And here we are going to input float band 5 minus band 4 divided by float band 5 plus band 4. Okay, and we are going to rename it as Ndvi 2018, save, and then OK. And here we are, this is the Ndvi of 2018. And we will do the Ndwi first as well. So this is the equation for Ndwi, which is green minus NIR divided by green plus NIR. Or for Landsat 8, it's band 3 minus band 5 divided by band 3 plus band 5. So here we are in the raster calculator. Like before, we'll put full band 3 minus band 5 divided by float band 3 plus band 5. Okay. So again, we are going to rename it as Ndwi 2018. Save. Okay. And we are done. Let's save this file as in the 2018. Okay. So here we can actually do some calibrations here, like properties. We can go to the classified version here. So there will be 6 classes. We can classify as minus 0.015, 0.14, 0.18, 0.27, 0.36, and 0.72. This will be our thresholds, and we will input like this. We will label it as well. This one will be water bodies. This will be built up area. It'll be barren land. It will be shrub and grassland. This one will be sparse vegetation, and the last one will be dense vegetation. Okay, so this is the Ndvi that we came up with. And for water bodies, we will change the color. For built-up area, we will make it red. Barren land will be black. Shrub and grassland will be this one. Sparse vegetation is quite okay. Dense vegetation will be this. So here you can see that in the year 2018, due to some Rohingya population, there weren't that much of dense vegetation. Anyway, so this is how we have performed the Ndvi. You can use it to make it a map. Now we will move to the Ndwi, and we will classify it as well. And there will be 4 classes, and the value of the classes will be minus 0.3, 0.2, and 1. Okay. And we can label it as drought, moderate drought, humidity, and water surface. Okay, and we should change the color ramp. I want to stick with it. And here it is, the value of Ndwi. As you can see, we don't have any water surface. Yes, we don't have any water surface in this picture. I just wanted to check it out by changing its color. So this is the Ndwi map of Ukia, and now we will move to Ndbi. Okay, so we will go to the properties. We will classify it. The classes will be 4. The classification is pretty easy. The first one will be 0, 0, y. The second one will be 0.1, 0.2, 0.1, and the final one will be 0.3. Okay, so the labeling will be non-built area. We will copy it, that's because we will record it later. Sparse built-up area, it'll be dense built-up area, we'll copy it all. And the last one is very dense built-up area. We will use pretty simple this one, and this is our Ndbi, our Normalized Difference Built-up Index. Okay, so now we have done those 3, calculating Ndvi done, calculating Ndwi done, calculating Ndbi is done as well. Now we will move to our next segment, which is to calculate land surface temperature. It has 5 steps, and now we will calculate it. So let's move on. So first of all, we will need to calculate the TOA, radians. The equation is pretty simple, and the equation is here. The final equation that we'll get for band 10 and Landsat 8. So now we will directly go for it. We will go to raster calculator. And now we will input the data. So it'll be 0.0003342 times the band 10 plus 0.100000 minus 0.029. Okay, so this is called the TOA value. So we will write just TOA 2018. We will save it. Let's check this out again. Yes, this seems correct. The next step includes conversion to top of atmosphere brightness temperature. So we will convert the TOA, or top of atmosphere, to brightness temperature, or BT. This is the main equation, and later the equation will turn out to be. If you want to find raster calculator manually, you can go to the Arc toolbox first and then come to the Spatial Analyst tool, and then finally map algebra, and there it is, raster calculator. So let's input that, 1321.789 divided by ln. We have ln here, this is ln. So ln of 774.8853 divided by our TOA value plus 1 minus 273.15. So this is the conversion value of the TOA, and we will convert it to the brightness temperature. And here it is. It's also doesn't look so sharp, but anyway, we will move to our next procedure, which is Ndvi calculation, which we have done before, so I didn't write it here. So here what we need to do, we will move to the step 4. That's because we already have done our Ndvi. So in step 4 we will calculate the land surface emissivity, or LSE, but before that we need to calculate the proportion of vegetation. So the equation of proportion of vegetation is Ndvi minus Ndvi minimum divided by Ndvi minimum minus Ndvi maximum, and it'll be whole square. So let's try to find it out. We have to move to Ndvi, and you see that I have classified all of it, but it doesn't matter. You can still find those minimum and maximum values. Go to stretched, write it somewhere so that we can easily access it anytime. So this is how we will get the low value and the high value. We'll just put OK, and we will go to the raster calculator once again, and then we have a square function here. We'll put the square, put another bracket here. So the Ndvi minus the value of minimum Ndvi, which was a minus, so it'll be plus, and the value of minimum Ndvi was 0.0979293. Okay, and divided by bracket Ndvi maximum, which was 0.46465,344 minus, but the Ndvi minimum value is minus again, so minus will be plus 0.097293. So this is how we will get the value for PV. We will save it as PV 2018. Let's save it, and OK. We will get a sharp picture this time, I believe. Yes. So here is the sharp picture, and we have calculated the proportion of vegetation here, and now we will calculate the land surface emissivity, which is pretty simple, 0.004 times that PV plus 0.986. So let's calculate it. So 0.004 times the PV that we have just calculated plus 0.986. This is the value of E2018. We have saved it, and then we are waiting for Arcgis to process the emissivity. Here is the emissivity, and for our final step, the LST calculation step, this is the final equation, and the values are this. So let's input this value. Go to raster calculator again, and then start with the BT divided by first bracket 1 plus bracket lambda. The value of lambda is 10.8 for band 10 times BT again divided by C2, which is 14,388 bracket closed times ln and the E that we have just calculated. So this is finally the value of the LST, and now we will save it as LST 2018 just to find it out later. And we will click OK, and we will be waiting for the final LST map to create. And here we are. We don't need to click all of those files here, so we can just minimize it. Now we will go to the properties. You can see that the LST map is not that convincing, it's not sharp, but doesn't matter. Let's classify it. There will be 4 classes. Classify, we will make it equal and interval, okay, and we will format the labels to be 2 so that the difference between the numbers will be 2, and we will move like the green one first. Okay, let's see. This is our land surface temperature map, and you can actually check the temperature by putting it here. For example, this one, it has a temperature of 20 degrees Celsius, and if you put it here, a comparatively higher temperature, and you will see that the temperature is 26.75 degrees Celsius. This is how you can create a LST map. The process is a bit long, but anyway, I believe you understood how to do it, and please give it a like, give your comments on this video, and share and subscribe to my channel. Thank you for watching this video.